Today we're going to talk about the switch endstop for the BigTreeTech SKR version 1.4. Now I need to explain some things. First of all, we have endstops for our X minimum, our Y minimum, and our Z minimum. Now these endstops now are used for something else, being power detection devices and other things. So we're just going to be talking about the optical endstop for this tutorial. Okay, this is the underside of the optical endstop, and as you can see, there is a voltage, signal, and ground for V, S, and G. Those correspond to the pins over here. Just keep in mind that no one's paying me to do this tutorial or sponsoring me, but I will be placing Amazon affiliate links in the description in order to help you find it better. Here's the top of the optical endstop. As you can see, there is a little line that runs down the center. Once that field is broken, it triggers the endstop to send a signal to our SKR version 1.4. So I'm going to show you how to hook this up now. What we're going to do is we're going to release this. What we're going to do to hook this up is we're going to apply the notched cable connection to the connector over here. But I have to let you know I traced out on the other end what the actual cable colors will be. So we have blank, which is signal, black, which is ground, and red, which is voltage. So we're going to go back to the other end of this. We're going to take the notch connector, we're going to turn this around, and we're going to connect it like so. So to connect it to the board, we already know from the previous tutorial that the top pin is voltage, the middle pin is ground, and the bottom pin is signal. So to connect this, what we're going to do is we're going to use the colored cables, and we're going to connect red to voltage, black to ground, and then finally the blank colored one to signal. Now to program it, we need to connect the USB serial cable. So I'm going to connect the big side of the USB connector to the board over here, and the small side of the connector to the computer, and you may hear a beep. Okay, first things first, as you can see, there's a firmware current file. Some people also call it a cursor file because of the extension. But for now, just note the date and time. So I'm going to go over to VS Code. And currently I have it open with the current download version of Marlin, which is 2.0.x. They've now included the SKR version 1.4 in their build for the release. So you can go over to Marlin, then go to source, and you can check right here under pins for the LPC 1768. It now has pins underscore BigTree underscore SKR underscore V1 underscore 4.h. And inside here it has the definition of where our pins are. So we're going to minimize this for a moment. And we're going to go over to our core folder, then our boards folder, and we're going to do a search on SKR, and we're going to copy board underscore BigTree underscore SKR underscore V1 underscore 4. We're then going to close out of boards.h. We're going to minimize core and source, and then we're going to go to configuration.h. And what we're going to do is we're going to do a search on motherboard, and we're going to highlight board underscore ramps underscore 14 underscore EFB, and we're going to paste what we just copied. And then we're going to change the serial port from 0 to -1. And then we're going to do a search on end stops. And as you can see, currently we have defined only the minimum end stops for X minimum, Y minimum, and Z minimum. And keep in mind, in the pins file, these are defined as something else, being other sensors for like power. But further on down here, we have float state. This has to do with the resistor on the end stop. It usually will even out your settings, so you can play with this as you would like, being uncommented or not. I choose not to use it, but other people may. And then we also have another preventing end stop float state here for a pull down resistor. So there's a pull up and a pull down. But then we have inverting. And in this case, with the optical end stop, we don't have to worry about inverting. But if you need to change the logic for, let's say, you're doing a detector for filament runout with an optical end stop, you may need to change this from false to true. But a little hint, if you're using an optical end stop for filament runout, it may not work in certain situations where the filament is clear. This is based on personal experience. But for now, we're going to go over to platformio.ini. And we need to change our default environment, which is our chipset that we're using, from the Mega ATmega 2560 to our chipset, which is the LPC 1768. And if you have any questions, it's down in this file, or you can verify that it's that type of chipset by going to Source, Pins, and inside Pins, the LPC 1768, we have our pins _ BTT, which is BigTreeTech, _ SKR _ V1 _ 4.H, and that is our chipset that we're working off of right here. So I'm going to minimize this, and instead of removing the micro USB, we now are connected via USB. So I'm going to do an upload with the upload button instead of just a regular compile. Now the upload button has compile features within it, and then it uploads to your device. So we're going to use that. So I'm going to click that, and that may take a few moments. Okay, once again, as you can see, the compilation is finished. It took about almost 3 minutes. Now, to verify that it actually finished compiling and was successful, it does say the LPC 1768 compiled. But to confirm it, what we can do is go over to our USB drive. And as you can see, it does have a firmware.bin. Now, keep in mind, the way that we actually need to do this now is to remove power from the board, and the way we're going to do that is to remove the USB. So note the time for the firmware in capital letters and what we currently have. So I'm going to remove the power cord, and you'll see what happens for the USB. And as you can see, it's updated to the time of the firmware.bin. What we need to do next is we need to test the end stop. So I'm going to go from here to my desktop where I have print run, open up Pronterface, connect to the SKR version 1.4, and I'm going to check the current status of the end stop, which is M119, and press enter. Right now it says open. So what I'm going to do next is place a piece of paper in the optical end stop. Now I'm going to do M119 again and send it. And as you can see, it's triggered. Now when I remove the paper and do M119 again, it says open. So if you like my tutorial, please press the like button and subscribe, and thank you for your time.